In this video, I'll be solving first part of the first problem of UPSC Civil Services Mains 2016 Statistics Paper 1. So let a box contains n tickets numbered 1 to n, and a boy draws n tickets from the box randomly. So if x1, x2 and so on xn be the numbers of tickets drawn, what is the expectation of maximum of xi? So if I consider like m as maximum of this xi's, so we are asked to find the expectation of maximum of xi. So for that, first if we find like probability that this maximum value is k. So that means if we are having like n objects or this n tickets, so the largest is k. So that means remaining n minus 1 must be less than or equal to k minus 1. So out of this k minus 1, we have to choose n minus 1. So that divided by number of total possibilities is, out of those capital N, we just have to choose small n number of tickets. So that's the probability of the maximum value of xi. So now like we need to find the expectation of m. So expectation of m is summation this k into probability that m is equals to k. So since we are taking n tickets, n tickets we are drawing, so that means this k will be going from n to capital N. So that means this is nothing but summation k is equals to n to capital N, k into k minus 1 choose n minus 1 by capital N choose n. So that is nothing but 1 by capital N choose n, summation k is equals to n to small n to capital N. So this will become k into, so if I expand, this is k minus 1 factorial by k minus n factorial into n minus 1 factorial. So that is 1 by capital N chosen, summation k is equals to n to capital N, k factorial by k minus n factorial into n minus 1 factorial. So if I multiply and divide by n, so this will become n by capital N chosen, summation k is equals to small n to capital N, k factorial by k minus n factorial into n factorial. So that means this expectation of this m is nothing but n by capital N choose n into, so this is nothing but k choose n. So k choose n, it's varying from, so that is like n choose n plus n choose n plus 1 choose n plus n plus 2 choose n plus and so on till capital N choose n. So now like by using Pascal's identity, so Pascal's identity n choose r plus n plus 1 choose r, n plus 1 choose r will just be n plus 1 choose r plus 1. So that's the Pascal's identity. We can compute the summation by using Pascal's identity. So this is nothing but n by capital N choose n. So if I write this n choose n as n plus 1 choose n plus 1, because n choose n and n choose n plus 1 choose n plus 1 both are equal to 1. So n plus 1 choose n plus n plus 2 choose n plus and so on capital N choose n. So that is nothing but n by capital N choose n. So this is nothing but n plus 2 choose n plus 1 plus n plus 2 choose n plus and so on till capital N choose n. So that is nothing but again like n by capital N choose n. This will just be n plus 3 choose n plus 1 plus n plus 3 choose n plus and so on till capital N choose n. So therefore like if we just compute this summation, we'll be getting n by capital N choose n. So capital N plus 1 choose n plus 1. So that is our expectation of m. So that is nothing but n by capital N factorial by capital N minus n factorial into n factorial into n plus 1 factorial by capital N minus n factorial into n plus 1 factorial. So that is nothing but, so these two will get cancelled. Then like here like we'll have n plus 1 and here we'll be having capital N plus 1. So this will just be n into capital N plus 1 by small n plus 1. So expectation of this maximum of xi will just be n by n plus 1 into capital N of capital N plus 1. So that's it for this video. We'll meet in the next video.